Hello guys, welcome back to my channel. Today is session 10 of deep learning for teens. So today I'm gonna mostly talk about actually BERT. So BERT is I try to explain it really easily. Okay, so we have no assignment for this session, but for next session I'm gonna have an assignment, and so next session I will complete the BERT, and also we're gonna have some assignment and other stuff that is related to that. Okay, let's get it started. First of all, BERT are based on transformer architecture. So next session I will talk about transformer as well. So this session I'm gonna focus on BERT. Okay. So if I want to tell you something about the BERT, I say this one. So BERT actually is a pre-trained model. So this is it's actually trained on the big data like Wikipedia and books. And if you remember, when I was talking about when I was talking about fine-tuning, so I told you we usually use a model that's already trained, and here in BERT actually we're using some models that are pre-trained, and we're gonna use that one as well. Okay, so during the pre-training it actually understand the BERT, understand the relationship between words, how sentences are structured, and other stuff related to each word, how each word is connected to other words. Okay, and we're gonna use BERT for sometimes tasks like sentiment analysis, as we talked about earlier, question answering, like when you ask a question, what's gonna be the answer, and text classification. We also cover this topic as well. So it's like a classification, but we only have text, and name entity recognition. So as you know, it is the meaning of a word. I mean, for example, if I say 2 p.m., we know the name entity recognition for this one. Name entity for this one is actually time. Okay, some stuff like this. We already covered that. So one more thing about this, why we cannot use embedding. So word embedding actually will work only for one word. So it means that's gonna convert one word, tokenize it, and convert it to a vector. But word embedding cannot understand the relationship between words. Okay, that's gonna be only about the word that we have. We don't know about the relationship between that word, and the other words that we have in our sentence. Okay, so we actually word embedding not gonna take care of other words in the sentence and relationship between them. So this is the reason we are using BERT. BERT will convert the whole sentence to a vector that is meaningful for our models. Okay, this is what word embedding cannot do. Okay, so if you remember, last session we talked about the word2vec and glove. Okay, so as I told you, that's gonna convert every word to vectors, but not the whole sentence. So BERT will do that job for us. All right, So let's go to coding part. I will describe this one as well. Okay. So if you see here, I just imported some libraries like TensorFlow, Hub. And by the way, TensorFlow Hub is where that you can find most of the models. And also, if you just Google it, you can find it out what I'm talking about. And also about the TensorFlow text. And here we have two URLs. These are the URLs for the models that we want to use. First one is the model that we use to tokenize our words. Okay, this is the first one, and the second one is for encoder. Encoder basically is our BERT, or this is the main model. So before giving the words to the model or giving sentences to the model, we need to pre-process them. So in other words, we need to tokenize them. So basically we need two models. So this is for tokenizing and the other one for encoder. Okay. So here, and by the way, if you just Google, if you just search these URLs, you can see the actual models. They have some documentation for that. You can read and understand it. Okay. So for the first one, we use this one here. So process URL, and as I told you, so this one is the URL that we are using for tokenizing, and this one is the one that we are using for encoder actually. So first of all, we have two simple texts here. We have text input. It contains two sentences, and this is a simple text sentence, and I love data science. So we're gonna give it to our first model because we want to tokenize it and prepare the data for our BERT here. Okay, and after doing that, we're gonna have a dictionary as output. So, and if you just search the keys, you can see input keys type IDs. Sorry. Input mask, input word IDs, and for the input type ID, it's gonna be like this. So if you have two sentences, it's if the word belongs to the first sentence, that's gonna put 0 here. Otherwise, that's gonna put 1 for the second sentence. Okay, but the point here is our model here consider this one as one sentence, and the reason is we seeing all of these 0 is because it's belong to the first sentence. Okay, because our model consider it like this. And for the input mask, tell BERT which position are real tokens and other position are padding. Padding means so we our model think like this. We need 128 tokens. Okay, so we're gonna have several tokens that are our actual words, but for the rest we're gonna put zeros. And for here, I also mentioned it in my presentation. So let's back to presentation. So for here, we're gonna have CLS, and also for the beginning of the token, and SEP for the actually for the last token that we have. So it means here, for example, we have my first sentence is like this. So let me bring it up. Okay, my first sentence is, this is a simple text sentence. Okay, 1, 2, 3, 4, 5, 6. So we have 6 tokens here. So we're gonna add 2 tokens to our sentence. So as a result, we're gonna have something like 8 ones here. So it's 1, 2, 3, 4, 5, 6, 7, 8. So, and for the rest, we don't have any token. So we just put zeros until we reach 1 to any 8. Okay. For the second sentence is a little bit different because the length of the tokens are not the same. So it's 1, 2, 3, 4, 5, 6. So it means we have 4 tokens in our sentence. And for the other one, it's like this. Input word IDs, also called segment IDs or token type IDs. So it's real token ID that we have. So as you know, so we have 2 sentences here. For the first sentence, we have 8 tokens. Okay. For the first one, it's like 101. So we have something here. For the last one, we have 102. Okay. So these are the same numbers, but for the rest are something like IDs, token IDs for the word that we have. Okay. For each word, we have a unique ID. And here, actually, we're gonna give the tokens that we have from the first model. We're gonna give it to encoder, and our encoder gonna give us something like outputs. We call it outputs, and again, it's a dictionary. If you check that, you can see something like this. We have bool output, sequence output, encoder output. And so I just put some comments here. You can read it by yourself, but I'm gonna mention this. What is important for us is this. So sequence output gonna give us each token by itself. So and the difference between pull output and this one is pull output will actually put all the tokens together. So if you see the shape, it's 768, sorry. And for here, it's like 128, it's 128 and 768. So the difference is this one actually put all the tokens together, and this is what we need for actually for layers that we have. So you can provide this one as input data for your neural network. Okay, this is what we're gonna do for next session, and that's it. I don't think I have anything more for this session. If you have any questions, just let me know in comments. As I told you, I don't have any assignment for today, but for next session, I will continue talking about BERT, and also I'm gonna talk about some related stuff that we need. Okay, guys, thank you so much, and see you in next session. Bye.